Okay, sketching the graph of a trig curve. So the first question, it's a cos curve. So cos curve starts at the top, middle, bottom. So this is one period of a cos curve. Obviously, it will keep going. So if I apply the A, which is a vertical stretch, that means this coordinate will now be 10, and this coordinate will now be at a height of -10. And I'm going to apply the B. So this x value is normally 2 pi. So I'm going to take the x value and divide it by b. So 2 pi over 2. So that is a division by a fraction. So I'm going to 2 pi times 2 over pi. So flip multiply because it's a divide fraction. That would cancel and it would equal 4. So instead of this being 2 pi, it's now 4, which I'm going to adjust all of these x values now. If this is 4, this is 1, 2, 3. Okay, so that's the A and the B. Now I'm going to do the C, which will go right 2. Okay, so I'm going to take all of those points and move them right. And this tells me I have to graph exactly from 0 to 6. 1, 2, 3, 4, 5, 6. And I'm marking this at a -10 and this at a 10. Okay, so this point is now going to be at the top at 2. Okay, so that point is now over there. And I'm just going to follow my pattern. So from there, the top, I went middle. So at 3, I'm middle. 4, I'm bottom. 5, I'm middle. 6, I'm back to the top. And then if I backtrack the pattern, so top, I have to go back to a middle and then back to the bottom. So that's exactly over the domain from 0 to 6. Okay? And that's it. Next one. Sketching the graph of a sine curve. So sine starts in the middle, heading up. So that's one cycle for sine. So I'm going to apply the A, which is 5, which means this new height from 1 is now going to be 5, -5 on the bottom height. And this x value is normally 2 pi. So I'm going to apply the B. So 2 pi, the x value, divided by b equals 2. So I'm going to cross it out. That's now a 2. So that means, what are the increments? If I do 2 divided by 4, it equals a half. So a half, 1, 1 1/2, 2. Now I'm going to do a whole new graph here, and I'm going to shift left 1. Okay, so be careful here. We notice that these are increments of a half. So I'm going to move this coordinate. I'm going to move it left 1. Okay, so we're careful of our increments here because each tick is a half, but we want to move left 1. Okay, so now I'm going to follow this point. So from there, I'm going to go up, mid, down, mid. So up, mid, down, mid, up. and so and so and so. Marking the top as a 5 and the bottom with a -5 height. So my x-intercepts are clearly labeled, and it says to graph at least one cycle. So I've done that. Sketching this graph, it's a coast curve. Okay, I'm going to apply the negative right away. So remembering the coast curve normally starts on the top. Okay, can you imagine flipping that, reflecting it? So now this is going to start on the bottom instead of the top. Middle won't change. This bottom will become the top. Okay, can you see my reflected coasts? Okay, now I'm going to put a 4 up here, a -4 down there to apply the 4 part. Okay, and then normally this has an x value of 2 pi, the end of the cycle. 2 pi divided by b. So that's a b. So then this is now going to be pi. Okay, so this is pi over 2. This would be pi over 4. This would be 3 pi over 4. Okay, because pi divided by 4 is a quarter pi, so each time you're going up by a quarter pi. Okay, so now I have to do a final graph on that interval. So we actually were pretty good here. I'm just copying what I did, and this ends at pi. So now I'm going to go quarter pi, half pi, 3/4 pi, all the way to a -pi. That's how much it says to graph over. So from there to there, I need to graph that. Okay, number 4, we don't need to graph it, it just says determine the period. So our period is normally 2 pi. That's the last x value we usually have. So now I'm going to divide it by a b. So that is a division in math by a fraction, which now will times and flip. So 6 pi is the new period. Number 5, so which, using this, the value of c that corresponds to the following graph is. Okay, so I'm going to kind of graph this. Okay, so -10 cos would mean my cos gets flipped. So that's going to be 10 and -10. Okay, so that has happened. Now, how did I get to this? Okay, so it looks like this bottom point, it obviously you can see it shifts up, but I would have to get a bottom point to 10. Okay, so therefore my answer is B. because I'm looking at this bottom point and this bottom point, and where would that have to go? We'd have to move 10. Graphing one period of this sine function. So a sine function normally starts middle heading up, like so, but I'm going to reflect that shape because I see a negative a, so I'm going to reflect that shape. So do you see how I reflected it? See the reflection? So now this is going to be up at 2, down at -2. Okay, so I'm going to take this x value right here. Normally it's at a 2 pi, but I have a b on the x, so I'm going to divide by 4. So that's pi over 2. I'm just reducing that fraction by 2. So this is now pi over 2. And it says to just do at least one period. So that is one period. So I'm just going to put arrows here because it's going to continue. This one's going to go up somewhere, and this one's going to go down to a low. Okay, and that's good enough. I have at least one x value and some y values. Sketch at least one period of this function. So 3 cos. So cos starts on a top. So 3 and -3 are now the new highs and lows. Okay, so I normally have a 2 pi on that x value right there. So 2 pi would get divided by a b. So now this is a 2. So this is now a 1, this is now a half, a 1.5. Okay, now I have a d, so I'm going to go down 1. So what I do is I often make some guidelines for myself here. So if I go down 1, I'm going to kind of draw that as my middle. And then 2 is now my top height instead of 3. And -4 is going to be my bottom now because I moved those numbers down 1. And there's no right and lefts. So I'm just going to continue the same way. So top, middle, bottom, middle, top. And I'm going to give myself an x value of 2 on that. And I'm going to draw arrows because this is going to keep going. It doesn't tell me to restrict it. Okay, number 8 is a reflected sine curve. So midline, instead of going up, I'm going to reflect it. So that is a sine curve reflected. Now this is my normally x value 2 pi, the end of the cycle there. I'm going to divide by pi over 2. In math, that would times and flip. So that is 4. So that is a 4, which means that's a 3, a 2, and a 1. And there was no vertical stretch, just a reflection, so that's a 1 and a -1 on the heights. Okay, so now I'm going to be moving this. I have to move it right 1 and up 3. Okay, so I'm going to give myself some guidelines here. The middle is going to be at 3. Okay, now here's my middle. And I only have an amplitude of 1, so 4 and 2 are going to be the top and bottom heights. Okay, so I'm ready to take that coordinate and I'm going to move it right 1, up 3. So that's that spot, right 1, up 3. So it's on the midline still. And then I'm going to continue the pattern. So midline, now I'm going to go down, mid, up. So here I need to be down. So the lowest was 2, back to the middle, 3, top 4. So this is an x value of 4. I need a 5 and a 6 because my domain up here says I need to go all the way from 0 to 6. So that's 4, back to the middle would be the next. And then at 6, I'm going to have to be at a low. So now I'm at 1 here, so I need to back it up. So the next in order here from mid would be the top. Okay, identify the graph of tan x. So we know that the tan of 0 is 0. The tan of 45 is 1. And the tan of 90 is undefined. And that's based off of our trig circle, our unit circle. Okay, tan, because the tan value, remember, is the y divided by x. Okay, so we need the origin, so this one, or this one, but the tan of there and there. This would be the graph that we're looking for. Sketch a graph at least one period of this function, so a cos curve. So top is the start. One and -1 because we didn't do any a's with it. Okay, so this x value, I'm going to deal with it. It's normally a 2 pi, but I'm going to divide it by a half, which makes it actually a 4 pi. So now these are going to be pi, 2 pi, 3 pi. Okay, this one is a little bit trickier. Let's see why. I'm going to be moving left pi over 2 and down 3. Those are my C and D numbers. So left and down. So first of all, I'm going to go 3 down and give myself some guidance. So there's my midline at -3. And I'm only needing to go 1 above it and 1 below it. So I'm going to make some markings here for myself. This is the top of the curve, the bottom of the curve, and the middle of the curve. Okay, so now this is the part that's going to be a little bit tricky because pi over 2 is not these markings. It's going to be right between those markings. Okay, so why don't we draw ourselves little tiny tick marks like that to show that we're going to be halfway between a pi over 2. Okay, so I'm going left. So this top point, I'm going to move the top point left. So it should be right here. See how I only moved it a half? So all your points will fall in line with halfway marks. So now from the top, I'm back to a midline, and then a bottom, and then a midline. And see how I'm lining them up with all of these little half marks in between. The next half mark, I need to be at a top. And that is one cycle, I can say. I can keep going, but I just need one cycle. State the amplitude. So the amplitude is part of the stretching. So our amplitude is going to be 2. We're going to have to go 2 off of our midline. Sketching the graph. So a sine curve, midline heading up. So there's the basic sine curve, and I'm going to apply the stretch, the vertical stretch. Okay, now I'm going to get this x value. So it's normally 2 pi. I'm going to divide it by the b. X gets divided by b. So this is going to make me times and flip. Pi's would cancel, and I'd get an x value of 6, which makes this x value 3, 1.5, 4.5. Okay, 6 divided by 4 is 1.5. Okay, so now we're going to take that graph. We're going to have to go down 2. So I'm going to draw some guidance. So there's my midline at -2. My top height is going to reach 2 instead of 4. And my bottom height is going to reach -6 instead of -4 because I moved everything down 2. Okay, so now I'm going to put this point from 0, 0. It's now going to go to the midline. I have to move it down 2. Okay, so there's that. Now I'm going to go up, top, midline, bottom. So remembering our x values here, that's a 1.5, that's a 3, that's a 4.5, back to a midline, which is at 6. And I have to go back to a -3. So 1.5 like that, so every 1.5. So the next midline, I would have to go down to a bottom and then back to a midline would be the pattern. Number 13, determine the period. So the period is 2 pi normally. And we would have to divide it by the b value. Okay, and that will cause me to flip multiply my fraction, which is 12. That's it. To sketch the graph over this domain, okay, so I'm going to go sine curve. There's my basic sine curve. And I'm going to apply the 5 stretch. So there's the 5. And this point, normal x value is 2 pi. But I'm going to divide it by b, which times and flip, which makes that an 8. Now I'm going to give myself more x values here. 2, 4, 6, 8. are the x values. And now the last piece is to go up 1. So I'm going to draw myself some guidelines here. The middle is going to be at 1. The top is going to be at 6. And the bottom is going to be at -4. Okay, so this is the first part I'm going to start with. That will be now right here, up 1. Okay, so 2, 4, 6, 8. So from there, I'm going to have to go to the top, middle, bottom, middle. Okay, and then I also have to go back to a domain of -4. So -2, -4. So I just have to do 2 of them. So continuing this pattern, so this is middle, I'm going to have to go down and then back to a middle. So make sure you're hitting that middle line. Sketch the graph of one period of this. So I'm going to reflect a coast curve. So -1 to 1, but I reflected it. And I don't think we have a b, so that's just 2 pi right there. So then this is pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so we're going to have to move left pi over 4 and up 3. So I'm going to draw my guideline at 3. So my mid at 3. I'm going to say my top height is 4. My bottom height is 2. Okay, because I have to go 1 up and 1 down from that. Okay, so 1, 2, 3, 4. So this was a 2 pi. Now this is a quarter, so I'm actually going to draw some little tick marks in between, because I'm going to have to shift in between, because pi over 4 is going to be halfway in that zone. So I'm going to be doing this on the left, because I know I'm moving left. Okay, so I'm going to take this coordinate where I started. I'm going to move it, it's a down, it's a low point, so I'm going to move it left. So it's going to go right here. Left, a quarter pi, and it's on the bottom. So now remember you're landing on all the little half ticks. Okay, so now I'm going to go to the next is a midline. So that's on the half tick. And the next half tick, I'm going to have to be at a top. Next half tick at a mid. And then at a bottom. Okay, arrows, I'm going to keep going. Okay, 16. So it's a sine curve. So midline, up. Okay, there's no A, so 1 is the top, -1 is the bottom. This x value is normally 2 pi. So then I'm going to divide it by that, which times flip. So 4 pi. Okay, so I'm going to make that a 2 pi, a 1 pi, 3 pi for my x increments. Now I need to shift this graph down 1. So the mid is -1. And 0 and -2 will now be the tops and the bottom. I went down 1. Okay, so let's put pi's on here. You know what, I'm going to do it on top. And I have to go to negative 2 pi. Okay, so I'm going to take the center point, or the starting point, so 0, 0. I'm going to move it down 1. So it'll be right here. Now I'm going to have to go to a top. So that'll be here. And then a middle. And I actually have to stop because it tells me to stop at 2 pi. So now if I have to go backwards to negative 2 pi, so this next is going to be a low and then a mid. Graphing at least 2 periods of tan x. Okay, so tan of 0, 0. Tan of 45 is 1. Tan of 90 is undefined. Okay, and if I do that going backwards, there's 1 cycle, and we're going to repeat. So next, so if I did 45, 90, so then this one would be at 135, where tan would be negative 1. The tan at 180 would be 0. 225 would be back to 1. And then at 270, you're going to have another asymptote.